Research. Flat Earth.
The history. Science or fiction? Pachamama Flat. Presence. Fomenko. Rebuilding the chronology. Chapter number 2. What is the story based on?
In our first film we discussed the glaring contradictions in world history, which have yet to receive a reasonable scientific explanation. Many questions are raised in today's accepted chronology, which was created and practically completed in the 16th and 17th centuries by the historian and philosopher Joseph Justus Scaliger and the Jesuit theologian Dionysius Petavius. From the most ancient times to the present day, the entire history of mankind is clearly dated. In numerous historical and archaeological reference books, you can find the answer to almost any question. In museums all over the world, unique exhibits are preserved that bear witness to a bygone era. You will hardly find among them any object bearing a plaque that reads, "Unknown origin" or "Unknown antiquity." All these objects are pedantically grouped and arranged in strict chronological order. But why have scientists come to the conclusion that, for example, this jar belongs to the 5th century BC, while this one belongs to the 8th century AD? In general, it is believed that the methods for determining the age of ancient objects are well verified and, more importantly, very reliable. In this film we will try to understand whether this is really the case. Is the history of the world really based on rigorous scientific evidence? It all starts with the excavations. Of course, what archaeologists are most interested in are the ancient settlements. That is where the history of the development of a particular people is concentrated. Any place where people have lived for a long time retains traces of their presence. Waste accumulates, old buildings are destroyed, and new buildings are constructed in their place. In almost every city that has a long and rich history, you can find a building like this one. It would seem to have sunk deep into the earth under its own weight. In reality, the reason is different. Bones, worn-out shoes and clothes, spoiled household objects, broken crockery were thrown out of the houses. This debris was covered with dust. People and animals dragged this debris with their feet, and the ground level gradually rose. Thus, over many centuries, a high cultural layer was formed. Archaeologists have not yet been able to determine at what rate these remains accumulate. In each individual case, the times are different, but archaeologists can find out which layer formed first and which formed later, and which one formed later. The study of the description of the cultural layers is called stratigraphy. For this, a slit is made or an exposed section of bank or gully is chosen, in order to clearly see the subsequence of all layers. The area is cleaned evenly and uniformly. But how do we know in which year or in which century each of the layers was formed? As a rule, each of the layers contains objects of some kind. They can be remains of wooden constructions, coins, pottery, jewelry, written documents, and much more. Thanks to them, each cultural layer can be dated, and for this purpose physical, chemical, biological, and other scientific methods are used to determine the age of the finds themselves. We will examine the main methods and find out if they can always be reliable to obtain an accurate dating of a historical monument. The method of dating by analogy is where it all begins. Once archaeologists have unearthed an ancient monument, they try to determine the age of the finds in situ. Utensils, weapons, ornaments found there. But the point is that even the same craftsman could not make two absolutely identical objects through ancient craft production. Therefore we do not find identical objects, but analogous ones. Hence the name of the method. Dating by analogy. It works as follows. Suppose a ring is found in Novgorod. For some reason, scientists come to the conclusion that it was made in the 12th century. Sometime later, in the Urals, archaeologists find another ring very similar to the one in Novgorod and come to the conclusion that it must also be dated to the 12th century. But why? Simply because they are similar.
This is a very clumsy method. We decide that they are about the same period, but here we run into a big problem. It could be a simple copy, totally coincidental. We are simply saying that it is similar, but it may have been produced at a much earlier or much later period. That is how we are wrong with this analogy.
Moreover, what one archaeologist considers similar to another seems different. The result is that the similarities and differences between things that are dated by this method are determined subjectively. Another very important point. Objects of value, cult or souvenir, could be preserved for a long time, passing from generation to generation. If an object is found in an old ruined house, and archaeologists date it to the 12th century, it does not mean that the house was built in the 12th century. Rather, it simply means that one of the occupants of the house has retained that antiquity in his possession. Conclusion. The method of dating by analogy is very subjective, does not have a strictly scientific basis, and does not allow to determine its exact age, not even its approximate age. It is believed that a cultural layer or a burial site can be dated by using the ancient coins found there. What does this mean? For example, archaeologists are excavating a settlement. none of the objects found tell them anything about the antiquity of that ancient settlement. But if coins are found, then there is a possibility to determine the age of that archaeological monument, since it is the coins that should contain the necessary information. We are used to the fact that on modern banknotes, both paper and metal, appear the names of the country, a portrait of the ruler or the founders of the state and, of course, the date of issue. But the fact of indicating the wedge date on the currency has become mandatory in all countries only in the last 200, 300 years. In ancient times and in the Middle Ages, it did not matter whether the coin was dated or not. So ancient coins bearing the wedge date are very rare. Of course, there are exceptions. The Film Chronicle has preserved for us a unique moment. Archaeologists pour on the table the contents of the clay amphora. These are the coins of the Bosphorus Kingdom, found in Crimea. The coins bear not only the name of the ruler, but also the year of issue. From this find a list of the Bosphorus Tsars, whose names had not been mentioned anywhere before, was compiled. But such finds are the exception, not the rule. But archaeologists argue that the age of the coin can be determined by other signs. For example, if it has the image of the emperor or king, or his name, then there is nothing easier. It is known when he ruled Carlo I, Henry II, or Ivan IV the Terrible. But is it really all so simple? In history there are examples where many years after the death of a ruler, his image remained for posterity as a kind of symbol that represented, even on coins.
The history of the coin wedge already has so many examples of deviation from some standards that, of course, there were cases when, well, for example, that coins with the name of Fyodor Ivanovich were manufactured at the end of the tumultuous period. Because for certain political forces, the name of this czar was a symbol of resistance. Although the czar himself had not existed for more than 15 years.
With the older coins, the problems were greater at that time, and many coins were minted that were imitations of old ones. For example, the Roman Empire minted its own legitimate coins with the image of the reigning emperor. Then these coins reached not only all corners of the empire, but also the neighboring territories that were in the sphere of political and economic interest of Rome. The tribes inhabiting those lands did not have, so to speak, a national currency of their own, so they imitated the Roman currency and made copies of the imperial coins. As a rule, the tribes imitated the best-known coins. This means that if the largest number of coins that came to them had the image of the Emperor Trajan, they minted imitations of these coins. And whether Trajan was alive or dead was totally irrelevant. After his death, centuries could have passed and imitation coins were still being minted. Another example is the famous Greek tetradrachm coin with the image of Alexander the Great. Over the years this coin of Athenaeus has been imitated everywhere, and spread along the Black Sea coast, Asia Minor, North Africa, and the Middle East. When finding such a coin in the cultural layer of an ancient city, it would be very difficult to determine the age of the coin itself and the age of the cultural layer. The portrait of the emperor would not be of great help in this case either.
On the coins of Alexander the Great his portrait was placed as if it were similar to the image of Hercules, that is, the portrait resembled, but, however, at that time it was not yet the style to place an exact portrait of a real existing person, such as Alexander the Great. But these coins were also manufactured, not only in the mints of this great Macedonian empire, but also in many adjacent lands. Therefore, we come to the conclusion that not always the portrait of a sovereign indicates that these coins were minted in the territory of his state during his reign.
But money is not only coins. For example, archaeologists during excavations of ancient Russian settlements often find not coins, but silver ingots. It is considered that the value of silver coins of that time was not very high, as silver coins contained a considerable amount of impurities. Therefore, coins were minted sparingly, and small ingots of pure silver were used. Well, the ingots have no dating, no date, no image, no stamping peculiarities. The only thing that scientists can do is to establish approximately the period in which the ingots were used. But of course it is impossible to date a cultural layer with them. There are also coins on which it is difficult to find dating features. They lack not only dates, but also inscriptions and portraits of rulers. Instead, ancient coins often bear images of animals, birds and flowers, and even insects. But without dates and names, these coins are nothing more than metal objects. It is not only difficult to establish the year of the coin wedge, but even which coin was minted first and which later. In some cases it is possible to determine where the metal was minted by analyzing the alloy. But it is impossible to establish the age of a coin in this way. Despite all the difficulties of using this method of dating, the finding of any coin is considered important for archaeologists.
It cannot be said that the dating of an archaeological layer by means of coins is the best or the most exceptional method. Everything is always relative, but in spite of this, no archaeologist will ever neglect the data yielded by coins.
Conclusion. The coin dating method cannot be applied if the coins found in the excavation have no distinctive dating signs. Such signs are absent in most ancient coins, therefore they themselves need to be studied and dated. In earlier times, as well as today, the most available material was clay, even for making household utensils. Pots, plates and jars were made in large quantities. It is not surprising, therefore, that the main material of almost all archaeological objects are huge lumps of pottery. That is, products of clay firing. To determine the antiquity of clay products, scientists try to use the archaeomagnetic method. All clay contains tiny iron particles, so it is susceptible to magnetization. But once the clay is burned, that is, fired at a temperature of more than 600 degrees, its magnetic field kind of stops, it freezes. The finished clay product remembers the magnitude and direction of the magnetic field of the earth where it was made. But to know after hundreds, even thousands of years, the exact age of this jar, for example, is very difficult. It is not enough to know how the magnetic field of the planet has changed over the centuries. You have to determine how it has changed in each particular region. But even that is not enough. You need more information about the jar itself. How it was placed in the kiln during the firing process, whether or not the kiln was evenly heated, and whether or not there were iron objects near the kiln. And these are just some of the questions for which it is almost impossible to find answers.
The archaeomagnetic method based on the Earth's magnetic field is very unreliable, very unstable, and, therefore, the dating, well, some amateurs try to determine them, but it is not a competent method.
Conclusion. Theoretically, the archaeomagnetic method is very interesting. But it is difficult to apply in practice. To determine the exact dating is practically impossible. In other times, time was calculated by means of hourglasses. This ingenious device could be found in every home of wealthy families. On the walls of the hourglass there are divisions that indicate how much time has passed. 5 minutes, 10 minutes, 15. Scientists wondered if they could use the same principle to find out the rate at which sedimentary layers accumulated on the planet. This idea quickly gained popularity around the world. But numerous studies yielded unconvincing results. The fact is that different rocks accumulate at different rates. Sand accumulates a few centimeters per year. Clay, 10 centimeters per millennium. In addition, each climatic area has varied rates of sedimentation. The same rock will accumulate differently in the tropics and in polar regions. In Egypt, for example, it is known that the buildings constructed during the period of Ramses II are buried under 3 meters of sand. It is considered that this pharaoh reigned about 3,000 years ago. This means that every 1,000 years a meter of sandy sediment was formed. But in some areas of Europe, during the same 1,000 years, only 3 centimeters of sediments have accumulated. In Lyman, in southern Ukraine, 3 centimeters of sediment accumulate every year. Here is another example. Scientists have found that limestone accumulates rather slowly, at the rate of a few tens of centimeters every 1,000 years. But in the Paracel Islands, on the limestone reef, at a depth of 1.5 meters, Spanish coins from the 15th century were found. If scholars are convinced that the coins were made exactly in the 15th century, this can only mean one thing. The initial calculation was wrong and limestone can accumulate at a rate of 30 centimeters every 100 years and not every 1,000.
Lately, this method has not been used. Understand that the attachment to certain archaeological antiquities is so conditioning that it cannot withstand any competition such as radiocarbon or any other.
Conclusion. The method of dating by sedimentary layers can be applied only to determine the age of modern deposits. For the dating of ancient deposits, it practically does not work. Scientists consider it a great fortune that an archaeological monument contains many wood fragments, because it becomes possible to determine the age of the object with an accuracy of 1 year. And so, determining the century of the object is not a difficult task at all. How? by means of dendrochronology. Let's see if this is really so. Dendrochronology is a method of dating archaeological finds and ancient objects. Dendrochronology emerged in the late 19th and early 20th century at the confluence of three sciences: geography, history, and biology. And in the year 1920, the American scientist Andrew Ellicott Douglas first applied this method to the dating of Indian ruins in the southwestern United States. The technological method is based on a law of nature that states that the thickness of a tree increases by one annual ring each year. Tree rings grow unevenly from year to year. If the year is warm and sunny and there is sufficient rainfall, the tree grows rapidly. The ring that grows that year will be wide. However, if the year is cold and dry, the ring will be smaller. It is believed that trees of the same species growing in the same location in the same climate have approximately the same thickness of annual rings. To find out when a found timber building was built. To do this, you have to construct and compare two graphs. One is a graph of the thickness of the annual rings of the building's logs. The other is a reference graph of a specific tree species. The dendrochronologist takes a piece of the fossilized tree and places it under a digital microscope. To obtain as accurate a graph as possible, the annual rings are investigated on 4 spokes. To obtain a clear pattern of the rings, the piece is cleaned and processed with chalk. The dendrochronologist counts the number of rings, determines their thickness, and, using a computer program, constructs a dendrochronological chart. In the same way, a graph is made for each of the timbers taken from the construction. Now, it is necessary to make a reference graph to build the longest possible scale. First, the oldest representative of the species must be examined. It is not necessary to cut down the living tree. It is enough to take a small specimen called kern. The specialist dendrochronologist, using a special drill, makes a small hole in the trunk and takes a small sample. The kern is placed under a digital microscope. Again, we will see on the monitor a clear pattern of annual rings. Thus the beginning of the dendrochronological reference scale is obtained. And here the first problem arises. The fact is that in European forests, for example, trees do not grow more than 400 years, at most 500 years. So, based on living trees, we can only extend our scale from the present into the past, up to about 1500 years. We can only scale up further with the help of dry wood, i.e. with already dead trees from which we can take samples. They are examined, just like the previous samples. By comparing the scale of the dead wood with that of the living tree, we find the so-called junction, i.e. the place where the same ring pattern coincides. Thus we can see when the tree was born and when it died. We extend our scale of reference some 500 years further back and arrive at the year 1000. At this point the second problem arises: how to continue building the scale. At the time, this problem was faced by scientists from all European countries. For the different species of wood, oaks, boxwoods, cedars and pines, and junipers, it was possible to construct a continuous scale until the year 1000 AD. From this point on, gaps appear.
They arise, what is called emptiness or hiatus, which is a Greek word that defines when there is a period in which we do not know how to specify what has happened, what happened. Then we need to accumulate data to fill it. Therefore, what is called scientific work? In scientific work we always encounter these same situations, which require the addition of materials, search for this material, analysis of this material or the development of new methods that allow more accurate dating of the materials, which we have already obtained.
It turns out that we can only determine the exact age of any wood find in Europe if the trees were felled in the year 1000 AD at the latest. It is in a more privileged place, American dendrochronology. There are trees that live up to 4,500 years. For example, the sequoia or the pilo. A single sample of a currently living tree can help us to make a scale of 4,000 years back in time. But this scale cannot be used to date a wood find in Europe or Asia. However, this is where civilization was born and developed. The main historical monuments of mankind are concentrated here. We were lucky with our specimen. These trees were felled around the middle of the 16th century. If the specimens had been much older, the dendrochronological method would hardly have been useful. But that is not the difficulty. In the application, to determine the age of any burial, it is not enough to find a single log in it. By sending it for investigation, archaeologists will only know the species of wood and how many years it was growing. For a serious dendrochronological study, several dozen logs are needed. And by far, not every excavation will yield that much wood. For this reason, if historians date a log found in the tomb of a pharaoh to millennia B.C., they do not do so as a result of dendrochronological research, but simply because of historical considerations. Another important role is played by how the wood was processed and how it was stored. During the processing of the wood, the builders stripped it of its outer layer, and that is several rings. And today it is impossible to know exactly how many.
Suppose you grab a log, and it should have a so-called last ring, an outer ring. If you don't have an outer ring, then we would be assuming, for example, that the last ring has a date, let's say 1200 years. But let's assume that you've had a few missing rings removed. And here we assume according to some data that we would talk about 20 rings roughly 1220 years. But there is no right to say that it is 1220 years. Here we only know that the last ring corresponds to the year 1200.
What if it is not 20 rings, but 100 rings? That would be a whole century. A successful application of dendrochronology in archaeology is considered to be the dating of the ancient pavements of Novgorod. In this town 28 layers of pavement have been discovered, laid one on top of the other, and they are not any semi-rotten remains, but 28 perfectly preserved layers of pine trunks. Examining annual rings, scientists concluded that it was a puff pastry built by the Novoros for 550 years. By acceptance, it is considered that the Great Novgorod was founded in the 10th century. So the first layer of the cake was laid immediately after the formation of the settlement. Greater Novgorod was founded on a swampy area, where it would have been impossible to exist without wooden floors. If we add 550 years, we reach the middle of the 15th century, where archaeologists locate exactly the upper part of the pavement layer. Does it mean that from the 16th century the inhabitants of the city stopped building new pavements, and until the appearance of asphalt, i.e. until the 20th century, they kneaded the mud of the streets with their feet? The archaeologists' explanation is that all the wooden floors and planks made in Greater Novgorod after the 15th century rotted away without a trace. It doesn't sound too convincing. Certainly, it is known that the bottom of this Novgorod paving slab is located in a swampy land, and the swamp spoils the organic elements very slowly. But why did these laws of physics apply only to pavements made before the 15th century? Although archaeologists consider the issue closed, the questions remain. One of two. Either dendrochronological dating methods may be wrong by 500 years or more, or the city we know as the Great Novgorod was founded much later than is believed, and its birth date should be considered the 15th century rather than the 10th century. Conclusion. Dendrochronology only makes it possible to obtain a more or less precise dating if a number of requirements are met. Most archaeological monuments do not meet all these requirements at the same time. Today, radiocarbon dating is considered the main method for determining the age of archaeological objects. This physical method is used to date objects and materials of biological origin. The method was proposed by the American physicist Willard Libby in the year 1947. Let us underline the fact that the radiocarbon method is only used to determine the age of organic objects. It can be used to date animal remains, wood, fabrics, and paper. The principle of operation of this method is as follows. All biological organisms contain carbon in the Earth's atmosphere as stable isotopes C12 and C13 and as the radioactive isotope C14. The isotope C14 is constantly produced in the atmosphere under the influence of radiation. The main source of radiation is cosmic rays. It has been estimated that about 7 kilograms of radiocarbon are generated and disintegrated in the Earth's atmosphere every year. Formed at an altitude of 15 kilometers, radiocarbon is oxidized with oxygen and dissipated in the atmosphere. It then enters the plants. Animals feed on plants and the radiocarbon reaches them. Man feeds on plants and animals, and along with them, radiocarbon reaches the human body. When a living organism dies, no more carbon enters it and carbon exchange ceases. This means that stable carbon is retained in the remains and radioactive carbon gradually decreases. Radioactive carbon gradually decreases. To know how many years have passed since the death of an organism, we have to measure how much radiocarbon has remained in it. Let's see what this looks like in practice. These images were taken in Ethiopia. They were provided to us by scientists at the Institute of Ecology and Evolution. In this African country, the scientists were on an archaeological expedition. During the excavation, antelope remains were found. To determine how much time had elapsed since the animal's death, the scientists took a fragment of the antelope's skull for examination. More specifically, the horn. And this, it is already in the laboratories of the Institute in Moscow.
Skull of a male. Yes, yes, yes. Horn was taken.
Scientists carefully inspect the obtained sample and prepare the fragments for analysis. To remove any impurities, the fragments are placed in a glass jar and treated with hydrochloric acid. After treatment, the sample is placed in a special oven and the analysis begins. This whole operation takes place in such a facility, where pumps are used to create a vacuum in all the flasks. The cooked sample is placed in this vessel, and into this is poured distilled water, which is then poured into the flask with the samples, literally drop by drop. The reaction starts and a colorless gas, called acetylene, is released. To collect it, flasks, called traps, are needed. These are frozen by liquid nitrogen. First the acetylene enters the first trap, and then the second. While the reaction takes place in the flask with the sample, a catalyst must be connected to the system. The vial with the catalyst is connected to the installation and placed in a special oven. In the flask with the sample, the foam has disappeared. It means that the reaction is finished and all the acetylene is frozen in the first trap. While thawing, it is necessary to attach to the installation a vial with activated carbon. After thawing, the acetylene in the second trap passes through a washing liquid, anhydride and bleach, and accumulates in the container containing the activated carbon. The washing liquid cleans the gas of any impurities, and the lye and anhydride removes water vapors. Acetylene gradually accumulates in this trap. It then falls on a hot catalyst which is removed from the furnace and placed in a flask with water. Benzene is formed at the bottom. The last trap is placed and the catalyst itself is placed back in the furnace. In this trap, we have the benzene we needed to obtain. After a few hours in the refrigerator, the benzene is gently injected into a vessel, which is then placed in a Musica complex. This counting machine has to calculate the radiocarbon age of our sample. The data obtained by this machine are entered into a computer program. We enter them into a computer program, which translates the radiocarbon age of the sample into its calendar age. The result of our study shows that the African antelope lived in the period between 790 BC and 510 BC. It would seem quite simple and straightforward, but do the results always correspond to reality? Is there ever an error?
What happens is that during radiocarbon analysis a rather complicated measurement system is used, and its operation, say, the work of photoelectronic multipliers may not be entirely stable, so the probability of an error is not small.
There are other factors that also affect the accuracy of dating. Above all, changes in the concentration of radiocarbon in the atmosphere. The C14 isotope is formed in the atmosphere under the influence of cosmic radiation, but the rate at which it accumulates has never been constant. For example, the activity of the Sun influences when it is high. The cosmic radiation reaches the Earth in less quantity when it is reduced, on the contrary, more. Radiocarbon formation is also affected by the strength of the Earth's magnetic field, which is also not constant. Another important point in determining the radiocarbon age of a biological object is to take into account the so-called bomb effect. After all, in the 50s of the last century, terrestrial nuclear tests were carried out. As a result, the concentration of radiocarbon in the atmosphere almost doubled. There is a group of organisms whose dating shows us the so-called imaginary radiocarbon age. This means that a radiocarbon analysis will show, for example, that any marine organism is much older than it really is. The fact is that the bottom sediments of the world's oceans contain a lot of radiocarbon. These sediments lie on the bottom for an enormous number of years, and the half-decay period of radiocarbon is 5,500 years. So in terms of radiocarbon analysis, this radiocarbon is very old, even dead. but it was and still is ingested by all marine creatures and gives them an age sometimes 1,000 years older than they are. There are also difficulties in dating wooden constructions. After all, the radiocarbon method only determines the period of death of the trees, and not the time when people built something with them.
For example, in Arctic conditions, it very often happens that a tree, washed ashore by the sea, floating, which is widely used by the locals for various household needs and as fuel, and above all for building. This tree may have remained on the shore for a long time. It could be several hundred years and only later have been included as part of an archaeological monument. Or perhaps the same piece of wood could have been used several times by the inhabitants. Hence the dating that we will obtain. From these wood fragments, they do not necessarily tell us the time of the construction of the monument. They tell us the time of death of the wood.
The situation with the dating of written sources is not good either. Often, museum workers ask the radiocarbon laboratory to date museum exhibits, including ancient scrolls. For their analysis, a very small fragment is enough. But, as a rule, museum workers do not know the whole history of storage of these ancient writings, i.e. who, when and with what they were treated to save them from rodents, insects, and various microorganisms. Therefore, the error in determining the age of such objects is quite large. Of course, scientists have computer programs that determine the age of the samples, taking into account all these factors, and recipes for cleaning organic materials from unwanted impurities. However, errors do occur.
There were some works, there are several. These works were carried out in large radiocarbon laboratories, in which large quantities of samples are dated. And well, in them it has been shown that approximately 1 out of 10 dating results, let's say, very different from its real appearance.
1 out of every 10 dates made by the best laboratories in the world is wrong. This means that at least 10% of the dates that scientists have used to date ancient objects are wrong. And they continue to use them.
There are hundreds of thousands of radiocarbon dates all over the world. This is essentially our most important pillar for deep dating, which goes up to 45,000 years. It's our most important dating method, yes, with some buts, and with some restrictions, but we didn't have better than this, so we're forced to base our conclusions on this method, and that's what we do.
Scientists often say that to determine the age of a biological object they never rely on the result of a single analysis. That only the coincidence of several measurements can guarantee an accurate dating. In the year 1988 was carried out, perhaps the most famous radiocarbon dating. It involved the radiocarbon analysis laboratories of the University of Arizona in the USA, the University of Oxford in the UK, and the Federal Institute of Technology in Zurich, Switzerland. Independently of each other, the scientists analyzed the fragments of a given canvas, using the blind method, which means that the researchers did not know what kind of samples had come to them for analysis. These were small pieces of the sacred cloak, a 4-meter-long cloth with which, according to tradition, Joseph of Arimathea had wrapped the body of Jesus Christ after his suffering and death on the cross. Since the year 1578, the cloak has been kept in a special ark in the Cathedral of St. John the Baptist in Turin. For this reason it is known today as the Mantle of Turin. On April 21, 1888, under the supervision of Cardinal Anastasio Balestrero, the Archbishop of Turin and invited experts, the Holy Cloak of Turin was cut from the Holy Cloak. A piece of about 7 square centimeters was cut from the sacred cloak, divided into 3 parts, and sent for examination. The 3 laboratories independently dated the fragments of the cloth to between the 12th and 14th centuries AD. But according to today's accepted chronology, Christ was born 2,000 years ago. And it turns out that, in this case, instead of answering the question about the age of the mantle, the radiocarbon analysis has only given rise to a new question. Either the sacred cloak of Turin is in fact a forgery, or the radiocarbon dating may have a margin of error of hundreds or even thousands of years. Or the mantle is an original. So what century did Christ live in? The debate has not ceased to this day. Conclusion. The radiocarbon method can only be applied to the analysis of objects of organic origin. The dating errors can be up to 2,000 years. For the dating of historical monuments, which are hundreds of thousands of years old, this error is acceptable, but for the dating of objects, which are only 2,000 or 4,000 years old, this error is not acceptable.
Fomenko.
Thus, we have considered the main methods used by scientists for dating historical monuments, and we have found that none of them is completely reliable. Unfortunately, the imperfection of all these methods leads to a large number of errors. Many of them have already become a dogma. And on their basis, new generations of historians continue to build erroneous versions of the events of world history. They are all wrong.
And archaeologists are also wrong. Do they think that while we excavate, we know exactly what happened there? Of course we don't. We hope that our physicists, chemists, and biologists will invent new methods. So far I don't see any of that. Except that we need to improve the current methods and gather new materials, which will help shed a light on what we talked about before, about those potholes. We have a lot of potholes, but we fill them.
In the 20th century, historians and archaeologists have come to the conclusion that in the last 200, 300 years, the vast majority of ancient monuments have deteriorated more rapidly than in previous centuries or even millennia. For example, large chunks of the Egyptian Sphinx, which supposedly has been there for about 5,000 years, are falling off. In reality, scientists cannot say precisely how fast the monuments were crumbling 1,000 or at least 500 years ago, because they have only been under constant observation for the past 2 centuries. Some scientists believe that modern industry is to blame for the destruction of the monuments, others that climate change and pollution are to blame. But all these assumptions have no firm scientific basis, because no one has ever conducted extensive international research. Most likely, all these monuments are not that old, and they are destroyed at a completely natural rate. Simply put, in order to determine the age of all this historical heritage, not only the usual methods should be used, but also other new dating methods must also be used. About the new mathematical methods for reconstructing historical events and to see how history is reconstructed by a mathematician, watch our next film. The truth can be calculated.
Pachamama flat.
Muy bien, ¿quién sos? Vos sos tú.